Look at all that delicious, delicious, delicious cmake.txt. Hello, welcome back. So today we're gonna, I don't know, keep changing gears in this thing. We're gonna keep doing things a little bit differently. Try a little bit differently this time. So we're gonna go back at it again. Got my STM32 F746. 746. I looked at some of the code that this thing generated for me, and I'm like, that's not the right numbers. Those aren't the right numbers. And then somebody mentioned to me, they're like, oh, well, you're using the cube thing, but then you're not, then you're using the chemesis, and the bisp. You're supposed to be using the cube. And I was like, it's the AI. Hey, knows what's going on. I don't know what's going on. So we tried a little bit. We're going to try just a tiny bit of like trying to understand how things work before we go at it. And today, I'm gonna like, all right, you know what, platform, you can go hang out, go have a nice time. I can't figure out how to include files or whatever, and it's giving me such a. So I've been chatting with a friend of mine over at DojoFive. So we're actually gonna try some of their. They've got some embed ops is what it's called, and they've got some dev containery kind of thing. So I'm gonna actually like load up one of their dev containers, and then use that tool chain that's in there and actually do make files. I mean, I'm not gonna make files, just gonna be make files. And we're gonna do some make files, and we're gonna do some STM32 vibing. We're gonna download some stuff, and we're gonna try a little bit. I'm gonna try to hold the hand of the AI just a little bit more than I have in the past. I'm gonna try to hold just a little bit, just a little bit. Because I've seen some examples of like, okay, this is how this actually works. So we'll try it out. With that being said, let's get started. All right, so we've got our DojoFive here. Modernize your embedded firmware development environment. So they've got a whole bunch of stuff. Oh, well, so embed ops is what we're looking at. There's a sign up kind of thing. There's a free version. There's a free trial for this. So that's what I've been working out of. So we have a login over here. I'm already logged in. So it drops me directly into the dashboard. So welcome to Embed Ops. There's a quick start guide that will guide you through setting up your necessary embedded development workflow and learn how to install the necessary dependencies. So they got a CLI. And the stuff that I'm going to be playing with, they've got a bunch of other stuff. They've got kind of like templates and layers and stuff that are out there. But what I'm working on today is I'm just going to use one of their development containers, and then I'm going to use that, and then I'm going to be inside of that and doing and stuff. So I'm going to use the embed ops to set up my development environment, then I'm going to go and do my development, and then I'm going to flash it using the ST-Link directly from the hardware, because don't get me started. Do not get me started with, oh, this is how OS X handles USB character devices, and this is how Linux handles USB character devices, and guess what? It's not the same. It's not the same. So, yeah, all right, anyway, so embed ops, the quick start wizard, so get started. So we got something, so they require dev containers, which is just Docker runtime. I use OrbStack for my Docker desktop environment. Embed ops is also like WSL WSL 2. So the way you install it, they've got a user local bin thing here. I'm just gonna install it in my home directory. So let me copy this out. Hop over to, so I've been playing around this Warp, which is an AI agent terminal thing, so that's fine. Let's see, and the part that I need from here is this curl. Let's see, can I? I'm just going to leave this directly inside of here. So there's this curl statement. I'm going to run it from my home directory. And then it pulls down a script and then runs it directly on SH. I think they've got a thing where it's like, oh, you need to run it as root, do it sudo. I'm like, I don't know about you, but running shell scripts as sudo, just out of the box, not for me today. Not for me. So it's pulling it down, downloading things. We installed it in bin.io. So let's find, okay, it's there. And then let's do a file. It's a Mako 64-bit executable, so I can't just like look at it and see what it's doing, so which is fine. So I'm going to do a make dir here, and let's say newly onioned. Okay, so newly onioned, and then I'm going to do EO. What's my quick start say to do? I already did a login, so I'm not gonna. That's good. When you do a login, it'll actually pop open a browser window, and then log into that, and then that'll launch it back. So that'll do that. So if you're depending on your default browser and everything, it'll work out okay. So that's how that works. Carpenter bees. All right, and then we do an EO init. Oh, that's right. I gotta, because I didn't put it in my path. Bin EO init. Project trial project was picked. Okay, so it's creating the repo here. Newly onioned with ID, downloading a template. I'm gonna use GitHub. Sure, GitHub. And then either none or Ubuntu. Well, we're gonna take Ubuntu, right? And it has applied our template, so it is now successfully applied. Next, set up your dev container. So it says add init. What does that mean? Okay, so we're just going to do that. /bin. And let's see, is this add init? Which is what? I think did I already do this? I don't know. Applying template. Okay, template successfully applied. Excellent. And then I'm going to be using ARM. So I'm going to do this one here. And then we're going to say ARM. Thank you. ARM none GCC build. I'm just going to do that. And so what that has done is it's added a dev container configuration file into my project, and then it's added different layers. And so it has that initial init layer, but then it also has this layer, which is just the ARM toolchain. So the ARM none GCC toolchain. Terminal command to build target. I don't know. We'll see. There you go. Build applying template. Template successfully installed. Okay. And then what I'm going to do is I'm going to open this directory inside of VS Code. Perfect. All right. I don't want to take a short survey. So I'm going to open, and what do I call it? Walking tomato and bad ops. Oh no, I put it in my home directory. Newly onioned. There we go. We're going to open it here. Yes, I trust the authors. It's asking me to reopen in container. So I'm going to say, yeah, of course, reopen in container. Show log. And there we go. Oh, connecting, processing. We'll trash that. All right, so here we are inside our development container for this. Let's see. Oh, no. Yes, yes. And then I want to put my RooCode extension in here. Install in dev container. Yes, please. Previously rookline. Interesting. All right, and it should have, let's check my configuration. Should have, yep, it's got my Gemini. All right, so I want to do this board. Okay, I want things to work on this board. So I'm going to just try to do a hello world on this board again. So let's see what we can do. Okay, all right, good. Okay, so it's creating a subtask to go and actually do the initial whatever. So it's going to do some make directories. STM32 hello world, source include docs, build, fine. Good. Okay. So it has created some directories. Thank you. Now it's going to create a README, project goals, initialize, blink the LED, print the spring. Okay. Okay. Hardware, discovery, MCU. Yes. Yes. IDE editor. Oh, okay. I can do that. Compiler. Yep. I can do that too. ST-Link. Board support package, okay. Awesome. Let's look at where are you at. So it's created a README file now. Project status.md, okay. Cool. Directory structure design document, status document that's happening right now. BSP integration, toolchain configuration, okay. Oh, I look forward to telling you about that. Let's see. Okay, I've got STMicros. 32F746G discovery BSP over here. Let's see, is there tags? There were tagged releases? Yes. I'm going to grab the tarball just in case. I don't think unzip is going to be part of the default. All right, so we've got our link. Here is the BSP link. All right, so now it is downloading and extracting the board support package from this. Okay, so it's going to try wget, put it in /temp, and then untar it into there. Okay, it's going to run command, but guess what? Ain't no wget on my system. What's up, dog? No wget it. That's right. That's right. What you going to do about it now? Curl. You need some curl. Let's do that. Do the curl. Boom. Did that work? Was that good? Was that enough? All right, update project status. Okay, so now it's going through the process of updating the project status. Good. So now it's got the board support package installed. The compiler. All right, so now it's going to look for the compiler toolchain. This is nice. I'm glad I asked it to do this. To do. I have, what is it? What do we call it? The ARM non-GCC build. Actually, let's look over here. There's a dev container docker. Dev container.json. We are including the ARM none EABI GCC dev. Okay, since you have that, we can proceed with setting up the CMake-based build system for the project. Yes, let's do it. This file will be placed in the root of this STM32 hello world directory. Feeling good. Feeling good. I'm gonna start plugging in my board. All right, so I just created a CMake list.txt. Okay, which has some drivers, the Simimsys, the HAL driver there. Okay, updated toolchain. Let's see, updated the board support package. Let's see, it should be, where are you at? It says it's updated. I'll delegate to code. Next crucial step, as noted, is what? What is it? Locate the startup file and linker script from BSP, copy them project root. Oh, interesting. Specific file name was not found directly. List the files in the BSP directory recursively to locate it. Okay. I hope there's a .s file. Didn't see, expected problem description, file thing. Wait, we're copying stuff? Oh, well, I don't know. Where did you put it? Let's go look around. We're just going to go /temp/ where did you remove it already? Maybe I didn't grab the whole package. I need the whole, but I don't, what do I want? Maybe I grabbed the whole thing. So let's, I guess that was just part of it. I need the rest of it too. All right, I tried to help. I really did. All right, let's go back over here to our discovery. That's just a component, okay. It's crucial that you use a consistent set of, as mentioned in this release notes. Okay, so we're gonna click here. All right, how do I download this whole thing? Yes, release notes for this firmware package. Graphical software configuration tools. So I want the whole thing. Simimsys cube project. Firmware, so this thing. All right, maybe this drivers project middleware. Okay, this looks more like it. All right, so we'll pull that down instead. Git clone recursive. Git checkout. I'm gonna clone it. Can I just pull it down? Did you have a release of it? All right, so I didn't get the whole one. Please remove the previous one and install this one. Okay, so it's gonna. No. I guess it. Wait, no. Please don't remove. Oh, just BSP start. Oh, jeez. Okay. Okay, wget doesn't exist. I don't know if you figured that out yet, but that's okay. No wget. Okay, now it's gonna curl. All right, better. Tar strip components 1. All right, run command. This feels like it should take longer. That's good. I wonder It's gonna remove the tarball just downloaded. No, that's fine for now. Maybe it'll do it right. Maybe it'll get everything we just need. There we go. It'll just extract the entire thing. Fine. So you've done it. You downloaded it. You extracted it to specific. View all the files. There you go. There you go. Find them all out. There should be some templates in there. You know, whatever else you want. Search for the linker script. Okay. Couldn't find the linker script. Are you sure? Please don't use the wrong one. Still haven't found it. Two linker scripts. Okay, that's good. Oh, okay, so there's an itcom flash and an axim flash, and you can use the axim flash? Yeah, it does. It seems like a more general purpose default. All right, so we're going to copy those to where? Startup, hello world startup.s. Okay, copy that to there. And then the linker script to there. Sure, you got it. All right, we're going to update the CMake list.txt. So that's been updated in some way. Changes are there. Update the comment message needs to be added. Okay. Now it's updating the project status.md. Build system complete. Wow. I like this. I like this project status thing. It's good. Located and copied. Okay. Updated CMake. Yep. Good job. All right. It's creating an initial main.c. You can see this up here. It's writing the task. So it's got, that's the prompt basically for it. And then this context thing, we are setting up a hello world project. There's the project root. Source files are here, include board support packages here, build system is here. Okay, specific instructions, create a new file and populate main.c with the following content. Basic, oh, look at that. It's putting all that there. Only perform the file creation. See, it's kind of like trying to constrain the agent into doing a very specific thing. Create this main.c. These specific instructions superseding conflicting general instructions your mode might have. It's crazy. All right, so there's my main.c, and that's it. And it's tut. Just did that. Sometimes the previous iterations I've seen it kind of like it keeps going, and the context window gets like a little out of control. So now it looks like the orchestrator mode is doing a better job of like controlling the context window. Okay, now it's updating the project status. So it's doing the thing and then having another agent go and do the project status. And so it's going to breaking it up into smaller tasks. System engineering for the win. Okay, now where it's at. So in progress, basic UART, hello world implementation, LED blinking implementation. Uh-oh. I don't see the LCD in here. Did it say LCD before? Did I tell it to do that? I put it on the LCD, right? Let's see what happens. Implement LED blinking functionality. Didn't ask for that, but that's fine. Okay, how and that. System clock config. CPU cache enabled. All right. Okay, LED blinking implementation is now complete. Current project status. Okay, updated. Okay, next major steps. Implement the UART. All right, so they're going to print hello world to the UART, which I don't care about. I don't want it on the UART. I want it on the screen. I want it on the screen. Updated UART. So now it's got LED pins, UART handle type. Okay, so it's added that portion of it to it. There's a UART1 in it. Now what are you doing? Updating project status to mark files, to mark complete. Compile project is in progress. Okay, so you're moving on to compiling project. All right, CMake-B build. You got it. Ready? Did not find compiler errors. Do I have to rebuild my container after I added those layers? Rebuild container. Okay, so it is there. I just had to rebuild it. That's weird. All right, I'm gonna close this out. Where'd my root go? Where'd my root go? Did you install? Let's see. How much memory do you have, Roo? All right. Yes. Okay, I'm gonna go change this back to orchestrator. Continue creating my project. You'll find the project status in a markdown file. Go. Yep. Project status.md. You can print it to the screen. I don't mind. Oh, and it's got a detailed log of the things that it did. What? I didn't even. So project's ready for its first compilation attempt. Look at that. It figured it out. Okay. Build and make. So it didn't find something. So that's in the build directory. Don't forget you're in the build directory. So it's updating that project status blocked failed. Attempting first failed due to missing C and ASM compilers. Okay, well, let's see what it wants to do now. Focus on milestone 5, which is environment variable. Okay, compilation failed. Okay. Oh, it did find it. Found both of them. Okay, good. Okay, it's updating. Don't need to modify cmake list.txt. Okay. But then why didn't it run? Well, you don't know what directory you're in. You're in the wrong, no such file or directory. I mean, that's not the problem, guys. The problem is that you're in the wrong directory. Yeah, you're good. You just don't know what directory you're in. Okay, specifically called out. Okay, okay. Is it going to figure out that you're in the wrong directory? You're already in the build directory. Okay. Nope, you're already. I don't know what to tell you, dude. You're already in the STM32 hello world build directory. You are correct. Okay, thank you. Run command. There we go. Did not find compiler ASM. No cmake C compiler. We provided pull paths, cache variables with the force option to make sure they use the specified values. Okay. Yeah, stop messing around, dude. Like, come on, cmake. You can do this. All right, run command. Oh, placed before the project command. Aha. Aha. Did you just realize that? I didn't know. Those have to be put in before the project command. All right, so it updated. I really like how this is keeping track of. It's like, I tried this, and then I tried this, and I tried this. That's really helpful. All right, try again. What? Okay, that's different. Undefined references. Now that's good. I like undefined references. Okay, identifies compilers but fails the C compiler check because it cannot link a simple test program. Skip the compiler check for bare metal. It will fail to link. Yeah, do that. Oh yeah, because I don't have GCC installed. All right, here we go. Build files have been written. Sweet, good job. Great. Object. So the compilation seems to work. Well, I should say the CMake version of the compilation seems to work. Now run the actual make. Do it, do it, do it. You're gonna make from that directory. Do it. Make. Bomb. Your include path is incorrect. Bomb. But I appreciate you updating that status file all the time. No such file or directory. What are you jumping into? Subtask results. So it's popping back up to the orchestrator and going to pop back down. Think this how. Are we supposed to copy that over? All right, still looking for header files. I bet you the code it spit out, it's solutionated, is using an older version of the SDK. Oh, so then it's going to look for the head. Oh, interesting. Search files for this. These are like example projects, which we need to find the core driver files. To get a clear picture of the actual driver locations, I'll list all of this to reveal the true structure, and help locate the necessary how and symmesis. So that header file isn't in there. You're looking for the wrong header file, buddy. All right, the recursive listing has provided more clarity. These HAL drivers are here. Okay, so they're going to add the includes for the Simimus and the HAL driver. Okay. Project status. All right. Well, I'm going to just close this one. You were already in, and it's going to fail again, but I'm just going to let this fail. Oh, sorry. Well, and make. Oh my goodness. What is this? CMake determine system, CMake, that's no such file or directory for that. Why is that in there? Task complete for now. You know what? That's good. Thank you. Thank you for just bailing on me right now, okay? And hopefully you wrote that out to the project status. That's the last one. Okay, so we're just going to cancel. We're going to cancel, okay? And we're going to terminate. I'm going to terminate, all right? No harm, no foul. We're just going to walk away. We're just going to walk away. So it's been fine. It's been about an hour. And we're going to say, that's it. That's it. We're done. We're done for today. You know what? And you've done a good job. Okay. You've done a decent job. You've seen how it's using, like, just giving a slightly different prompt. It's forcing it to, like, actually document its own steps, so then it can share those steps that it's doing with itself in the future, which is a different itself. So, like, you think of these things, they don't have memories. Like, they have a certain amount of memory, but they're not memories. So they got to have them write down the memories of the things that they've done. So yeah. All right. Well, I'm feeling good so far. I don't know. Maybe it's a little optimism. Maybe it's a little unfounded optimism. A little bit of relentless optimism. So I'm feeling good so far. I'm okay with this scenario. I think it's going to figure itself out, but we'll keep working on it. So I'll come back and we'll do this. We'll just keep following this path. We'll keep following this path next time. So hop down there in the YouTubers and smash them. Do the smashy on the buttons, and do those things. Like and subscribe, and we'll see you next time.